In the next two videos, we're going to talk about web analytics. So there are a number of different social media accounts. Maybe you have Twitter or X, maybe you have Instagram, maybe you have a website, or maybe you have a YouTube channel. And we can analyze information that is collected relevant to these sites. And so let's just talk about how we collect that information, how we can analyze this information. So this particular video is going to look at a YouTube channel and the type of analytics you can pull from it. And the next video will look at Twitter, or X, it's calling itself these days. And so what you can do is you can look at other social medias like Instagram, and you'll see combinations of these two types of data sources. All right, so let's take a look. So first thing is when you are looking at your particular data source that is web-based, we need to figure out how to export our information. So all of these web-based sources have a way to export the data. And so here's how to export from YouTube Studio, right? You go into your YouTube Studio account, select Analytics, and then you can download reports based on the amount of time that you want to look at. In comparison, in the next video, we'll look at Twitter and the process for exporting from Twitter. So you'll need to first find that method for exporting the analytical data from your particular social media provider. Or if you have a website and it's being hosted, then you can either pull the analytics from the host if they provide that service, or what you can do is you can pay companies like Google to monitor your website. So you have to initiate, typically pay, for the process to start tracking. And then what happens is that then after a period of time, you can download that data. So we'll just look in this video at YouTube and the next video at Twitter, but you're gonna find similar information depending on what source you're looking at. All right, so we want to export from YouTube Studio. And then once we have done that, we then are going to get from YouTube, for example, a bunch of CSV files. And so in order to work through these CSV files, you can go to drstephpowers.github.io/BIA. And we are working through in our next two videos, web analytics here. So looking at different data sources. All right, so when you click in here, not only will you find the workbook, which you can open in Google Colab, and you can then save a copy for yourself to edit, but you will also find the different CSV files from this YouTube example. And then for our next video, you'll find the Twitter documents as well. So you'll have access to that. All right, so let's go into our workbook here. And because in your life, you're going to need to be accessing your own data, you will export, for example, from YouTube Studio your data, throw it into your Google Drive, and then you would need to be able to access that to analyze it. So what we're doing here is we're linking to our Google Drive. So we're going to import pandas as PD and import numpy as NP, our standard, our most used packages, followed by matplotlib. And then we're linking this particular workbook to our Google Drive. When you do this, you are linking your workbook in your Google Drive to the rest of your Google Drive so you can pull files. Does not give access to anybody else. So I'm giving my workbook access to my drive, and I do that each time I open the workbook. All right, so once I have mounted my drive, then I can port in the different types of data that I can collect from YouTube, for example. So one of the data sets you can get from YouTube is the total number of views. And so we can take that information and we can see we just get, here's a particular date, here's how many people watch those videos. So now we're testing you on those videos when we looked at data visualization, figuring out based on this type of data, what is the appropriate type of visual? Well, here we have time. And we're looking at views over time. So we create a line chart. So let's import matplotlib.pyplot as PLT. We already imported numpy, so technically don't need to do it again. And so to actually create this chart here, we'll do plt.plot, total views. The column is views. And we are here, we just have it, we can silence this axis here. And that way it doesn't show the actual dates because it's not really relevant. What we're looking for is more of the pattern in the views. We haven't specified here what's on the x-axis, And that's because there are these dates here, but we don't need to see all of these dates. In fact, let's just get rid of these numbers here because they don't matter. So where we have set that the X-ticks would have been a rotation, copying the code from our data visualization video, what we'll just do is give it an empty bracket. And when we give it an empty bracket here, we now have removed that time period. So now that we have this data here, we're looking at views over time. We could then create a forecasting model. So in future videos, we'll be looking at forecasting methods. And so we could forecast future views. And you'll notice there seems to be a cyclical pattern to this. Maybe it's seasonality. Maybe there are certain views at certain times of the year, or maybe it's views at certain times during the week. And so we could then create a forecasting model that actually allows for the seasonality. If the seasonality is going to be based on months or weeks, then we could use a SARIMA model, and we have a video on how to do that. If we want to identify there's a difference between a weekday and a weekend, then we would use a profit model, and we'll have a video on that. So once we pull this information, we can then analyze and forecast what is happening in terms of the views. Can we predict the views, and can we identify what's causing this up and down in the data? Other types of data we can collect here. There is a document it creates called age.csv. And so we can just make my image here a little bit bigger so I can read this better. No reason for it to be teeny tiny. All right, so here we can look at the age data, and so it shows viewers by age group. And we can look at the percentage that they are the viewers of, the average view duration, the percentage that they view. We can look at watch time and percentage as well. So if we're looking at parts of a whole, in terms of the breakdown of viewers or watch time as a percentage of who watches this particular channel, what kind of data visualization would we use? Well, we use a pie chart or a donut plot. All right, so we could do that. And if we are not looking at view percentages or watch time percentages, but instead looking at, say, average view duration, so we want to see and compare that each of these age groups, how long do they watch a particular video? And so if these videos are 15 minutes, what we're seeing here is that typically people watch for about 2 or 3 minutes, which is why, TikTok is popular, because people only want to watch for about 2 minutes. So if we want to compare the average view duration, then what is the appropriate data visualization tool? Well, for comparing, then we want bar graphs or column charts. For this particular example, we'll just look at watch time hours percentage. And so we need to then make a pie plot or a donut plot. So we import numpy as np, import matplotlib.pyplot as plt. If we're going to create a donut plot, you'll recall from our data visualization that we need to have it explode. So it's a pie chart that gets exploded, and we add a white circle into the center. So we'll need to add the number of explodes equal to the number of different categories that we have. So we can look at what is the length of one of these variables here, like watch time hours percentage, and find that there are 7 rows. And so we need then to put in 0.057 times to explode for our donut plot. Our data we're actually looking at is watch time hours percentage. And then the labels are going to be the viewer age. And then we're just copying this code from our data visualization video so that we have that center as a white circle. When we do that, we get a donut plot that looks like this. We can see the different labels here. We see that with this little one, because these both have 0, this overlaps. We can get rid of that by actually doing the labeling by hand, and so then create empty labels instead of having the labels for, if we go and look at 13 to 17 and 45 to 54, have very small. So we could actually just specify the labels as 18 to 24, 25 to 34, and then just make them blanks for the 2 labels that have that are really have a very small number or percentage so that this doesn't overlap. So we can clean up this graphic if we're building a dashboard, for example. Now let's suppose that we are looking at content. So one of the things that YouTube outputs is information related to content. And so if we import that in, what we see here is information about particular video titles, how many views, how many watch hours, how many subscribers, and average view duration. It has its own metric for impressions, what percentage click through, and you can see here in terms of how much money each video makes. So in this case, let's take that amount of money and let's also create a pie chart, a percentage, parts of a whole visual for this so that we can see of the money that these videos make, is it evenly broken down between videos? Or in this case, what we'll see when we do this is that we have here, you can just see here, we have one video that makes more than a quarter of the money comes from one video. So in this case, what we do is use matplotlib.pyplot as PLT, import pandas as PD. If you're building this type of visualization, we need to first drop the total row. So in these, they'll have a total, and so we need to get rid of that. So we're going to drop index 0. And then some of the videos nobody watches or don't make any money, and so we need to drop any that don't have any revenue for them. So what we're going to do is we're going to take just that one column, estimated revenue, drop the first row, drop the NAs, and then we can build a pie plot here. There's a lot of videos. There's 500 and something videos, so that's why it takes a second. And we get the bit of this blur here. We can address that blur same way we just talked about in the previous one, which is we can remove the labels specific to those to address that. But here, the takeaway in this case is that one video is almost a third of all the money. Other types of information you can collect from YouTube is you can collect information as to the type of device that people are using when they watch their video. If you're doing this for Google websites, they collect the same type of information. What kind of device are they visiting the website on? So this is the information you get. And I encourage you to try to create some data visualizations to summarize this information. Other things that that's collected are gender, and so we can import that information. It has 3 categories here: female, male, and then user specified something else. And here then you can break it down. Who are you appealing to? What are the demographics of the people who visit your website by age, by gender? Who are the people who watch your TikTok videos or visit your Instagram? So we can do some analytics to better understand who the customers are or who the viewers are so that you can target your videos or your content appropriately. So you can do this type of analysis from this output. And of course, that's why often these web-based data sources, they'll often provide a summary for you. By doing this, then you can even break it down further and look at statistical significance, right? In terms of, we could take our viewership or the average view duration and look at some more information. Here we also get geography. So in this case, we're getting geography by country. So who is visiting your website or watching your YouTube channel or visiting your Instagram. And so what we can do is we can actually create what's called a choropleth map. And this choropleth map is going to take this information like number of views or watch time hours and put it onto a map itself. So I'm just going to scroll down so we can see the end product. This is a choropleth, and a choropleth takes polygons. And so in this case, the polygon is the area of a particular country. So on the map, basically have lined out the edges of a country, and then we're putting data into that polygon and color coding it for different levels of viewing and and I should have made this scale as opposed to just random numbers here. So we'll have to fix that in a moment. But then we can show, for example, darker colors indicate more, lighter colors indicate less. All right, so how do we go about making a choropleth map? So what we're going to do is we need to click on the wrong things. That's always helpful. All right, so first we need to import our information in. So this is a geography.csv file. And when we look at it, what we see is that we see a column called geography. And you'll notice it has a totals row. So just like in our previous one, we'll have to figure out how to deal with that. And then you'll notice that for the Google output, it has it as a 2-digit or an alphanumeric code that's two digits here. To represent the different countries. Now, when you are doing choropleth maps with Plotly, which the benefit of that is we can put it into our dashboard in later videos, is that requires you to use a alpha 3 code. So we will need to convert this column here where we have a 2-letter representation of a country into 3 in order to match it to the mapping capability. So let's just create that map. Let's do our geography and let's do our number of views. Okay, so in order to do this mapping of the alpha 2 code to alpha 3 code, you're going to need to install something called ISO 3166. So we'll do a pip install of that. And then we will import that. So from ISO 3166, we will import countries. Then what we're going to do is we are going to create an empty list called country_names. And we're going to do some filtering of this table. So first thing we want to do is get rid of the total. And we need to get rid of the total row. So that's what we have here. Remember, this exclamation equals means not. So we're going to find the geography that is not equal to total. And we're going to, essentially, we're removing that and we're making everything else a string. So we want to recognize it as text. And then what we're going to do is we're going to also filter out of the data set here any NANs. So anywhere we don't have any information, we will pull that out as well. So we're going to do that filtering. And then what we're going to do is create a loop. So for country, this word country is just a placeholder. We are going to, for country in, and we're going through this geography list here. What we're going to do is we're going to go through that geography list and we're going to get the country that goes with it. And we're appending it to this empty list. And what we're then going to create is a new variable we'll call ISO alpha. And so we'll add a column to this table here. And that is going to give us the country names. But the country names here, this label that we're getting here from this get country, what it is at get country, it's pulling not truly the name, but it's pulling the alpha 3 code. So this here, this loop, and creating this new variable is going to add to your table the 3-digit codes. The first part here, so we need this empty list. We should probably actually rearrange this so it's clear. We put this because this is related to the loop. And this first part here is just prep, because when we go through and try to find the 3 code alphas here from this, there's no equivalent to total, so it doesn't know what to do if you do that. And if there are NANs missing information, it doesn't know what to do there either. So we're kind of filtering those out first, converting it to a string so that it recognizes as text, which is the format it needs then to pull the information. It's basically doing a lookup table like you would in Excel, right? So we're looking it up there and pulling that information and adding it as a table. So when I do that here, my filtered version, I have my geography, the original 2 alpha code, the views, which is what I want to put on my graph. And then I have this new column here. I called it ISO alpha. You can call it whatever you want, alpha 3, whatever. So then what we're going to do is we are going to plot these views. Now, if you go and you plot it just as it is, it doesn't recognize that these are actually integers or counts. And so when we go to create the plot, like we saw just a couple minutes ago, it had a different color for every country because it's not recognizing that those views are actually counts, right? It's thinking them as more of labels. So what we need to do is specify that they are an integer. So we're going to take that column of views and we are going to do as type int to make sure that it knows that these really are counts, which then allows us to color code darker colors for a higher number of views. So we need this row here so that it recognizes that those are counts. Then we're going to import Plotly Express as px, and we need that in order to create our choropleth. Then what we're going to do is we're going to use from Plotly Express, we are going to create a choropleth, and we're going to use this geod filtered table here. And the locations are going to be the ISO alpha column because we need that 3-digit code. And the location mode is ISO 3. So this has to be in this 3-digit format because the choropleth itself is looking for that 3-digit format, the 3 alpha codes. We're going to color code based on view. And then when it says hover over the name, when you go over a different country, what do you want to appear? And so we can use the column geography, for example, if you want the 2 alpha code. If you want it to be the 3 alpha code, then change this from geography to ISO alpha. And then we want it to create our figure. Now we want it to be a color scheme where it is darker colors is more views. And so that's this color continuous scale. There are color sequential choices you can choose from choropleth. We could make this oranges, we could make this blues, we could make this greens. Here it's just a single color scale, but you're welcome to go and take a look at other different types of color schemes. If you leave that color continuous scale off, then it is going to just put random different colors. So what we can see here is we've created a choropleth map that shows the number of views. So in Russia, the number of views have been 36. There's 159,000 views in Canada, 327,000 views in the US, and looks like the third highest is India. So you can look at who is viewing your website, who is watching your TikTok videos, and we can lay it out on a nice visual. We could even, because this is in Plotly, we could turn it into a dashboard. So create a dashboard that would then show us and summarize everything about our viewership. So whenever you have different data visualizations that are using Plotly, then we'll be able to put them into our dashboard, and we have a video on Dash later on. There are other types of data you can pull from the YouTube just to show you. The other one you can get is operating system. So what kind of operating system are people visiting your website or your social media from? And then we can also look at source. And so how did they get there? And so we can look at, did they search YouTube? Did they come from an external site? Was it recommended to them? Did they go directly to there? So you can try to figure out how people are finding out about your social media. And we can then actually turn that into a graph. So we have the number of views here. We have the watch time hours. And so you can plot that right in terms of bar graphs and column charts. All right, so you can see the different variety of information you can collect from a website, from a YouTube video that are specific to like the demographics of the individuals who visit your site or watch your videos. And this will help you analyze who's coming to your site, where are they coming from, what country, who are they in terms of their characteristics, what type of devices are they using. Also, you can better appeal to your customer base. If you know how they're coming to you, that changes how you advertise. If you know what type of devices they're using, a laptop or a mobile device, you can ensure that the visuals you're using are easily seen and viewed in that type of format. So for example, if we're watching things on a phone, then having small detailed text, kind of like this one here, is maybe not appropriate. We need things that are much bigger and can be seen on a tiny device versus on a bigger device. So we use our web analytics to explore who are our customers, how can we better advertise to them, promote to them, cater to what they're looking for in order to increase the amount of traffic on our particular site.